Okay, so work. This is what we're going to learn this week. So, what is work? Work is a change in kinetic energy. Okay, a change in kinetic energy. So, what is kinetic energy? Kinetic energy is the energy caused by velocity. So, what does that mean? Basically, anytime you have a change in velocity, you have work being done. And anytime work is being done, you're going to have some sort of a change in velocity. Now, first thing we have to focus on right now is distance versus displacement. So this is one of those things where you don't really think it matters until you really hit work, where distance versus displacement is huge in work. So if you're like me and you wake up in your bedroom and then you wander over into the kitchen, get some breakfast, eat a little bit, stare at the fridge, come out in the living room, sit on your couch, hang out for a little bit, go into the kitchen because you want more food, come back out, go into the bathroom, brush your teeth, take a nap, come back out into the living room, and then watch the news, which makes you run into your panic room and hang out for a little while. And then you come back out into your living room and hang out, and then you get some dinner, and then finally you end up back in your bedroom where you go to sleep. Because you start and stop in the same place, your distance is going to be different from your displacement. If you're like me, then you have wandered around your house for varying between tens and thousands of feet. So we'll just add in a nice little 500 feet, call it a rough average. However, because you start every day in your bedroom and you end every day in your bedroom, your actual displacement is zero. So that means if you wake up and you go out and you do tons of yard work and you just put in a lot of effort, and then you end your day back in your bed, according to physics, you have done no work. So, work is force times displacement. This is the formula right here. So, work is W. It's measured in joules. We have force. Your force is in newtons, of course. And you have displacement. And your displacement is measured in meters. Now, there is a trick. For those of y'all that are really good with math, this trick will be really obvious. For the rest of us, however, we're going to have to think a little bit before we figure out what the signs are. So as I'm looking out my window right here, I saw this deer. This deer, it was giving me a weird look, but this is a very accurate portrait. Yeah. But this deer, of course, was just hanging out. He was not moving. Okay? And so because he was not moving, he has no displacement. And if we remember that work is force times displacement, no displacement equals no work. So if you're not moving, I'm sorry, you're not doing any work. You might be doing homework, but according to physics, you're not doing any work. Of course, also in this category, if you have something that's moving in a constant velocity in some direction, but has no force acting upon it, that also counts as no work. So no displacement, no work, no force, no work. Now, what about if we have like two sports ballers here? Okay, so we have a bulldog tackling some sort of player from a bird school. No, it's not Ellison. That's just what ended up happening. So our bulldog here is applying a force in the positive direction. And they also have a displacement in the positive direction. Okay, so you'll notice force and displacement are both in the positive direction. So if force and displacement are in the same direction, that means you have positive work. So that should help you sort out your signs for all the rest of it. So if we look at the other case, however, so my rabbit, Dr. Chunky, check out one of my other videos if you actually want to see what she looks like. She is not very good at stopping before she runs into walls. So she tries, though. So, like in this case, she sees the wall, she tries to stop, so she applies a force in the negative direction. However, she will continue to travel in the direction of the wall, so her displacement is in the positive direction. So if you have force in one direction and displacement in the opposite direction, when you have force and displacement in opposite directions, we call that negative work. Just to help you sort your signs out. So let's go over this in general. If you have no motion or no force, you have zero work. If your motion is in one direction and your force is in the same direction, you have positive work. If you have motion in one direction and force in the opposite direction, you have negative work. So 0, we have no change in kinetic energy. If we have positive work, that means we add kinetic energy. And if we have negative work, we remove kinetic energy. Now, if we remember, energy is a conservative quantity. It cannot be created or destroyed. So when we say we're adding and removing kinetic energy, what we really mean is we're transforming it from a different type of energy into kinetic energy. Now, there's one other thing that a lot of physics problems like to add in, and that is work done by gravity. Okay, gravity does work. It's a force. And like if you're in this situation where you've obviously just been kicked out of an airplane, hopefully, well, that's a self-portrait. Hopefully Mr. W here, which is me, has a parachute, but who knows? But what we do know is we have a force of gravity in the negative direction, and we have a displacement in the negative direction. Okay, so the trick on this one is they won't usually tell you that what your force of gravity is. Instead, they will tell you like you have a mass of 100 kilograms. Okay, so what you have to do in this case is remember the force of gravity is equal to mg. And we learned all about this last week. So in the case of work done by gravity, you get mg times your displacement. So in this case, let's say we have a displacement of, I don't know, 600 meters. So the work done by gravity is equal to 100 times 9.8 times 600, which gives you work done by gravity. And if you remember, these are both in the negative direction. So negative displacement, and we're going to have a negative force. Go ahead and calculate that out. We have 100 times 9.8 times 600 gives us a really obnoxious number, 588,000. So that's going to be 588,000 joules. So that's the end of part 1. Part 2 gets a little bit more complicated, but these are the basics, and let's face it, that really wasn't that much work.